Morning everybody. Today we are going to see about uh, today we are going to see one electrical circuit problem given in SEDIQ. It is a practice problem from third chapter and it is 3.1. The question is to obtain the node voltages and the answer is also given. So now we are going to solve that particular problem. So this is the problem given and it contains two current sources. And it has two nodes, node 1 and node 2, and we name the node voltages as V1 and V2. The currents flowing through these paths are named as I1, I2, I3, I4 and I5, and the ground is at the potential 0. Actually the current will be flowing between two nodes. So this I1 current is flowing out of this current source. I2 current flows between this first node and the second node. I3 current is flowing between this 1 and ground, and this I4 is flowing out of this second node and enter into this current source, and this I5 current is flowing through the 7 ohm resistance to this ground, and the voltage will be measured at a particular point or a node. The voltage is measured at a point or node with respect to ground. Okay, so this concept you should know, and we are going to solve this using Kirchhoff's current law. So what is the statement for this Kirchhoff's current law? It states that at any node the sum of incoming currents is equal to sum of outgoing currents. So what are the incoming currents at node 1? So this is your node 1, and what are the current flowing into this? It is I1 current. And what are the outgoing or leaving currents at node 1? At node 1 the leaving currents are I2 and I3. What are the incoming currents at node 2? It is I2 that is entering into second node. And what are the outgoing currents at node 2? They are I4 and I5. So using this Kirchhoff's current law, we write the equation for this node 1. Here I1 incoming current is equal to the sum of outgoing currents I2 and I3. So at node 2, the incoming current I2 is equal to sum of outgoing currents I4 and I5. We should also observe that this I1 is equal to 3 amp current and this I4 is equal to 12 ohms. And we are going to use the Ohm's law as a formula, and that I is equal to V by R. Sometimes it is also the V is the potential difference, V1 minus V2 by R, like that it comes. Okay. So basic things we know. Now we are going to solve this. So at node 1 I1 is equal to I2 plus I3. So this I1 current we know that it is 3, that is equal to I2 that can be written as this V by R. Okay, so in that V1 minus V2, so it flows from first node to the second node. What is I3? I3 is the current I3 is flowing from first node to the ground, so it is at potential V1 minus the ground potential is 0 divided by the resistance is 2. So you get it as 3 is equal to V1 minus V2 divided by 6 plus V1 by 2. So 3 is equal to on this side. So if you take the common denominator at right side, it is 6. So V1 minus V2 plus 3V1, isn't it? So you can make it as, if you cross multiply this 3 and 6, then you will get it as 18. So if you cross multiply 3 and 16, you will get it as 18. 18 is equal to 4V1 minus V2. So we rearrange it like 4V1 minus V2, that is equal to 18. This is our first equation. Now we go for second node. So at node 2, current I2 is incoming and I4 and I5 are outgoing. So we have this equation already got. So now we are going to substitute the current values. So I2 current is not known, but we can write V by our formula. So I2 is equal to that potential at first node, okay, V1 minus V2 divided by the resistance is 6 ohms. That is equal to I4. So this I4 current, we know already that it is 12 amps. So it is 12 plus what is I5? This I5 is the current which is flowing through this 7 ohm resistance. So it is from V2 potential to the ground potential divided by 7. So we get it as V1 minus V2 divided by 6, that is equal to 12 plus V2 by 7. So V1 minus V2 divided by 6. This V2 by 7 comes to this side. So it is minus V2 by 7, that is equal to 12. So we can take this common denominator. So it is 6 into 7, that is 42. So here you get it as 7V1 minus 7V2 minus 6V2, that is equal to 12. So you get this as 7V1 minus 13V2 divided by 42, that is equal to 12. So it can be written as 7V1 minus 13V2 is equal to 12 into 42, that is 504. Now you got the second equation. So we are going to solve this. V2 is equal to 4V1 minus 18. So this is taken out of this first equation. Now substitute this V2 value in this second equation. So you get 7V1 minus 13 into this V2 is 4V1 minus 18. That is equal to 504. So it is 7V1 minus 13 into 4, 52V1 plus 234. That is equal to 504. So 7V1 minus 52V1 is equal to 504 minus 234. So this is equal to 270. So 7V1 minus 52V1 is minus 45V1, that is equal to 270. So V1 is equal to minus 270 divided by 45. So it is equal to minus 6 volts. So what's the answer for V1? V1 is equal to minus 6 volts. So we got first answer. One answer we got. Okay. Now substitute this V1 as 6 volts in the first equation or second equation. Let me choose the first equation. So it is 4 into minus 6 we have found out, right? Minus 6 volts minus V2, that is equal to 18. So it is minus 24 minus V2 is equal to 18. So minus V2 is equal to 18 plus 24. So it is 42. So V2 is equal to minus 42 volts. So we got the second answer too. V2 is equal to minus 42 volts. This is the second answer. So now we verify our answers. So this is V1 is minus 6 volts and V2 is minus 42. So we got the correct answer. Okay. Thank you.